All right, let's take a look at this antiderivative. 1 over x minus 5 times x squared plus 4x plus 13. Let me say at the outset, this is going to be a lot of work. To get started, we find the partial fraction decomposition. 1 over x minus 5 times x squared plus 4x plus 13. So I have a linear term and an irreducible quadratic. The linear term has a over x minus 5 for its part of the expansion. For this irreducible quadratic, I would have bx plus c over x squared plus 4x plus 13. And to solve for a, b, and c, I clear out the denominator. So 1 is equal to a times x squared plus 4x plus 13 plus bx plus c times x minus 5. Okay, from this point forward, there are two options. I can multiply out and match coefficients, and that would give me a system of 3 equations and 3 unknowns. The alternative is to plug in numbers. One easy number that I can plug in is 5. So plugging in 5, I get 1 is equal to a times 25 plus 20 plus 13. And so plugging in, that gives me that a is 1 over 58. Okay, now there's another number that I can plug in that will make my life easy now that I know this one, and that's 0. If I plug in 0, I get 1 is equal to, plugging in 0, I would get 13a, and I just got done saying that 13a was 1 over 58. So 13 times a, 0 and 0 here. Plug in 0, that goes away. Plug in 0 for here, I get negative 5c. And so 1 is equal to 13/58 minus 5c. And if we solve for c, we get that c is equal to negative 9 over 58. Okay, now we have one variable left, the variable b. I can plug in any other number I want, and that will allow me to solve for b. I'll plug in something simple like 1. So 1 equals, plug in 1 into here. I get a times 1 plus 4 plus 13 plus b minus 9 over 58 times negative 4. 1 minus 5. And so it's a bit of a mess, but there's only one variable here. That's the b here. So we get that 58 over 58 is equal to 18 over 58 minus 4b plus 36 over 58. And so bringing things over, we get that negative 4b is equal to 4 over 58. And therefore, b is equal to negative 1 over 58. And so our expansion is going to be 1 over 58 over x minus 5, and then negative 1 over 58x plus c, so minus 9 over 58 all over x squared plus 4x plus 13. Okay, so there's our expansion. So let me repeat this down to the bottom of the page. Antiderivative of dx over x minus 5, x squared plus 4x plus 13 equals. So I'm going to copy down what I had at the top of the page, 1 over 58 over x minus 5 plus negative 1 over 58x minus 9 over 58 over x squared plus 4x plus 13 dx. All right, so here we go. So let's split this up. I have 1 over 58 antiderivative of dx over x minus 5. Then over here, I can pull out negative 1 over 58, and I have x plus 9 over x squared plus 4x plus 13 dx. Okay, this I can integrate. I'll save that for later. This part here, I would want to make this a u substitution. So I'm going to let u equal x squared plus 4x plus 13. Then my du would be a 2x here. So I'm going to force there to be a 2x here so that I can do a u substitution later. So 1 over 58, integral of dx over x minus 5, I'll do that later, minus 1 over 58 times a half, integral of 2x plus 18 over x squared plus 4x plus 13 dx. Equals 1 over 58, and I derivative of dx over x minus 5 minus 1 over 116 integral. All right, now the bottom here is x squared plus 4x plus 13. What I really want to have on top is 2x plus 4 so that I can apply the u substitution. So I'll write it like that. And then I also have antiderivative of 14 dx over x squared plus 4x plus 13. So I split this up, 2x plus 4 plus 14 is 18. And I split it like this so that the numerator here is the derivative of the denominator. Okay, so to continue from here, we'll apply u substitution. So we'll let u be equal to x squared plus 4x plus 13. And therefore, my du would be 2x plus 4 dx. And so I can apply u substitution on this part. So continuing on the next page, bring this down a little bit. We get that this is equal to 1 over 58 integral of dx over x minus 5 minus 1 over 116 integral of du over u. And I know how to integrate that. This part over here requires a little bit more thought. I can write this as minus 14 over 116 integral of dx over x plus 2 squared plus 3 squared. So I'm completing the square here. X squared plus 4 squared plus 4 plus an extra 9 makes 13. So I complete the square on the bottom and I get this. All right, the reason I do this is so that I can now integrate. Here I have 1 over 58 times the natural log of absolute value of x minus 5. Over here I have 116 times the natural log of absolute value of u. And here I have 7 over 58. And I look this up. This is one of the formulas that I should have handy access to if I don't have it memorized. This is 1/3 times the arctangent of x plus 2 over 3. And that's one of the formulas that you should have used in Calculus 2, plus c. So continuing, we get this is equal to 1 over 158 times the natural log of absolute value of x minus 5 minus 1 over 116 times the natural log of u, which was x squared plus 4x plus 13, minus 7 over 174 of the arctangent of x plus 2 over 3 plus c. And one last bit of bookkeeping. This thing can never be negative. No matter what, this can never be negative. In fact, the smallest it can possibly be is 9. So the absolute value signs are superfluous. And so I can write this as negative 1 over 116, natural log of parentheses, x squared plus 4x plus 13. There's no danger of this ever being negative, minus 7 over 174 times the arctangent of x plus 2 over 3 plus c. And so that is the antiderivative of this function.